described situation is unusual, where the operation of an air conditioner improves satellite television picture quality. Typically, electrical appliances can introduce interference that degrades signal quality. There are a few potential explanations for this inverse effect. Firstly, grounding issues can be a contributing factor. The electrical system and the satellite dish system should be properly grounded to a common ground point. Poor grounding can lead to voltage differences between the systems, creating noise and interference. When the air conditioner starts, it might be inadvertently improving the grounding situation, perhaps by creating a better path to ground or by stabilizing the voltage potential between the two systems. It's possible that the air conditioner's installation incidentally corrected a pre-existing grounding problem. Secondly, interference problems may exist. While appliances usually introduce interference, it's conceivable that the air conditioner is somehow mitigating existing interference. This could be due to the air conditioner's electrical components acting as a filter or counteracting another source of interference. Perhaps there's another appliance or device in the home that is generating noise, and the air conditioner's operation somehow reduces that noise. This is less likely, but still a possibility. Thirdly, voltage regulation is key. The operation of the air conditioner could be affecting the voltage supplied to the satellite receiver. Satellite receivers are sensitive to voltage fluctuations. If the voltage is unstable, it can affect signal processing and picture quality. When the air conditioner starts, it might be stabilizing the voltage, providing a cleaner power source for the satellite receiver. This is more plausible if the home's electrical system has voltage regulation issues. The air conditioner, with its significant electrical load, could be acting as a buffer, evening out voltage spikes or dips. To troubleshoot, firstly, inspect the grounding of both the electrical system and the satellite dish. Ensure that all grounding connections are secure and properly bonded to a common ground point. A qualified electrician can perform a ground resistance test to verify the effectiveness of the grounding system. Secondly, check for loose connections in the electrical wiring, especially in the branch circuit serving the satellite receiver and the air conditioner. Loose connections can create voltage drops and introduce noise into the system. Thirdly, investigate potential sources of interference. Turn off other appliances and devices in the home one by one to see if any of them are contributing to the problem. This includes things like fluorescent lights, dimmer switches, and electronic devices. Fourthly, monitor the voltage at the outlet supplying the satellite receiver. Use a multimeter to measure the voltage when the air conditioner is off and when it is on. Look for any significant voltage fluctuations. If the voltage is unstable, consider using a power conditioner or voltage regulator to provide a clean and stable power source for the satellite receiver. Fifthly, examine the satellite dish and cabling. Ensure that the dish is properly aligned and that the cabling is in good condition. Look for any signs of damage or corrosion. Use high-quality coaxial cable and connectors to minimize signal loss and interference. Sixthly, consider the possibility of harmonic distortion. Harmonic distortion is a type of electrical noise that can be generated by nonlinear loads, such as electronic devices and appliances. The air conditioner might be affecting the harmonic distortion in the electrical system, which in turn affects the satellite receiver. A power quality analyzer can be used to measure harmonic distortion. If harmonic distortion is a problem, a harmonic filter can be installed to reduce it. Seventhly, check the satellite receiver's power supply. The receiver's power supply could be failing or be sensitive to voltage fluctuations. Try using a different power supply or power conditioner to see if it improves the picture quality. Eighthly, consider the age and condition of the air conditioner. An older or malfunctioning air conditioner could be generating electrical noise that is affecting the satellite receiver. Have the air conditioner inspected by a qualified technician to ensure that it is operating properly. Ninthly, review the electrical panel. Ensure that the wiring to the air conditioner and satellite receiver are correctly sized and that the circuit breakers are in good condition. Overloaded circuits or faulty breakers can cause voltage drops and other electrical problems. Tenthly, it's also worth noting that sometimes seemingly unrelated electrical events can have unexpected effects on sensitive electronic equipment. The interaction between the air conditioner and satellite receiver might be due to a complex combination of factors that are difficult to isolate. If the problem persists, consult with a qualified electrician or satellite TV technician for further assistance. Explain the symptoms and the troubleshooting steps that have already been taken. They may have specialized equipment and knowledge to diagnose and resolve the issue. By systematically investigating these potential causes and implementing the suggested troubleshooting steps, you may be able to identify the reason why the operation of the air conditioner improves the satellite television picture quality. The NEC, or National Electrical Code, provides guidelines for safe electrical installations. Article 250 covers grounding and bonding requirements. It specifies the methods for grounding electrical systems and equipment to ensure safety and minimize the risk of electrical shock. Proper grounding is essential for preventing voltage differences and reducing electrical noise. Article 300 addresses wiring methods and materials. It specifies the types of wiring that are permitted for different applications, as well as the installation requirements. Using the correct wiring and installation methods is crucial for preventing electrical problems. Article 310 covers conductors for general wiring. It specifies the ampacity of conductors, which is the maximum current that a conductor can carry without overheating. It also provides guidelines for dirting conductors when they are installed in certain conditions, such as in conduits or in close proximity to other conductors. Using the correct conductor size is essential for preventing overheating and voltage drops. Article 400 addresses flexible cords and cables. It specifies the types of flexible cords and cables that are permitted for different applications, as well as the installation requirements. Flexible cords and cables should be used only for temporary wiring or for connecting portable appliances. Article 500 covers hazardous locations. It specifies the requirements for electrical equipment and wiring in areas where there is a risk of fire or explosion due to flammable gases, vapors, or dusts. Electrical equipment in hazardous locations must be specially designed and installed to prevent ignition. Article 600 addresses electric signs and outline lighting. It specifies the requirements for the installation and wiring of electric signs and outline lighting. Electric signs and outline lighting must be installed in accordance with the NEC to ensure safety and prevent electrical hazards. Article 700 covers emergency systems. It specifies the requirements for emergency power systems such as generators and battery backup systems. Emergency power systems must be installed to provide power to essential equipment during a power outage. Article 725 addresses Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. It specifies the requirements for the installation and wiring of these types of circuits. Class 2 and Class 3 circuits are typically used for low-voltage applications such as doorbells and thermostats. Article 800 covers communications circuits. It specifies the requirements for the installation and wiring of communication circuits, such as telephone and data cables. Communication circuits must be installed in accordance with the NEC to prevent interference and ensure proper operation. NEC Table 310.15b16 provides ampacity ratings for conductors. This table lists the maximum current that a conductor can carry based on its size, insulation type, and temperature rating. When selecting conductors for an electrical installation, it is essential to consult this table to ensure that the conductors are properly sized. NEC Section 250.24 covers grounding of service-supplied alternating current systems. It specifies the requirements for grounding the neutral conductor of a service-supplied alternating current system. This grounding connection is essential for providing a low-impedance path for fault current to return to the source. NEC Section 250.50 covers grounding electrode system. It specifies the requirements for the grounding electrode system, which is the system of electrodes that are used to connect the electrical system to the earth. The grounding electrode system must be effective in providing a low impedance path for fault current to return to the source. NEC Section 250.122 covers size of equipment grounding conductors. It specifies the requirements for the size of the equipment grounding conductors, which are the conductors that are used to connect the metal enclosures of electrical equipment to the grounding system. The equipment grounding conductors must be sized to safely carry fault current back to the source. In conclusion, the systematic approach to troubleshooting, combined with a solid understanding of electrical principles and the NEC, will help in resolving the issue of improved satellite television picture quality when the air conditioner is operating. Remember that working with electricity can be dangerous, so always consult with a qualified electrician if you are not comfortable performing electrical work yourself.